everybody, in this video we're going to go over more examples of finding the first terms of a sequence with multiple occurrences of n. Now I have made another video on this, but I do want to go over two more problems that are slightly different, or they vary slightly from the previous video. This problem, a sub n equals -1 to the n times 2 to the negative n. Again, what we need to do is we need to plug our n's in one at a time. So our first term, a sub 1, is going to be -1 to the 1 times 2 to the -1. Now why is this one a little bit different? Well, -1 to the 1 is just going to be -1. But then 2 to the -1 is 1 over 2 to the 1, right? Because we flop it to the denominator if it has a negative exponent. Now if it's a negative exponent in the denominator, it flops to the numerator. So this becomes -1 over 2. If you don't believe me with that, this is -1 over 1, and then we multiply straight across. So our first term is -1/2. Our second term we're going to find the same way, but now anytime we see n, we're going to plug in a 2. So we get -1 squared, which is a 1, times 2 to the -2, which is 1 over 2 squared. So here we end up getting 1/4 for our second term. Our third term, let's find it the same way. We get -1 cubed 2 to the -3, which is -1 times 1 over 2 cubed. Multiply across, we get -1/8 for our third term. And for our fourth term, we get -1 to the 4th power times 2 to the -4. So this is a +1 times 1 over 2 to the 4th power. So our fourth term is equal to 1 over 16. So what are the first four terms? -1/2, 1/4, -1/8, and 1/16. Now the next problem I'm going to talk about talks about factorials. So if you need help with factorials, I have a video on factorial expressions. Let's go ahead and take a look at that one. So here is our sequence that has a factorial expression in it. We do it the same way, where the first term, it doesn't want me to write there. Let's zoom back out. The first term, a sub 1, is going to be 2 to the 1 over 1 factorial. Now, here's my n's, and I'm just plugging those in there, one in for all of those. So this equals, well, 2 to the 1 is just 2, and 1 factorial is 1. So our first term is going to be 2. Doesn't want me to write here. Okay, my second term, I plug in 2 for all my n's. 2 squared over 2 factorial, which is equal to 4 over 2 times 1, which 4 divided by 2 is 2. Okay. Now, our third term is equal to 2 cubed over 3 factorial. 2 cubed is equal to 8, and then 3 factorial is 3 times 2 times 1. I can go ahead and multiply across the denominator and get, this is 8/6, right? And then reduce it. Divide each by 2, we get 4/3. Now from here I could also say, well, 8 over 3 times 2 times 1, that's not going to make much difference though. If I take 8 and divide it by 2, I get 4 in the numerator, and then I have 4 in the numerator over 3 in the denominator. So either way, will work. But that is my third term. And then my fourth term is equal to 2 to the 4th power over 4 factorial. Now, 2 to the 4th power is 16. And then I have divided by 4 times 3 times 2 times 1. I like to reduce it before I multiply things through. 16 divided by 4 is 4. And then I also, so that equals 4 divided by 3 times 2 times 1. Now I have a 4 divided by 2. That reduces again to a 2 on the numerator. So this is equal to 2/3. So there are my first 4 terms of this sequence with the factorials.